Acha guys, we have to discuss the stretch of functions today. Before we do that, let's see how do we stretch different shapes. How do we geometrically stretch different shapes? Look at this triangle ABC. Right now, this point A is 5 comma 2, this point B is 10 comma 2, and this C is 7 comma 4. Okay, we have 4 over here. Now, if this x-axis over here is the invariant line, okay? This x-axis over here, that is your invariant line. And I want to stretch this with a scale factor 2. See, how would I do this? I have to see that how far this point A is from the x-axis. So you can see this is 2 units away from the x-axis. This B is 2 units away from the x-axis. And this C is 4 units away from the x-axis. Now I have to multiply these distances with the scale factor. Now this 2 into 2 is 4. So within this, on the same locus you mark here, here is going to be your A dash, which is now 4 units away from the x-axis. Similarly, this B is going to be here 4 units away from the x-axis. And this C dash would be 6, 7, 8 over here. So that is how you mark this C dash over here. Okay. So if I show you this joined together, so here is the image of this triangle. You can see that the triangle has been vertically stretched. Okay? Similarly, if you look at this triangle PQR and let us stretch this from y-axis, okay? Let us stretch this from y-axis with a scale factor half, with a scale factor half. Okay, now right now, this point Q is 5 units away from this y-axis. So I'll be halving that distance. So that would be here at 2.5. So here is your Q dash. Similarly, your P is also 5 units away from the y-axis. So I half that distance. So here is a new location for the P dash. Look at this R over here. This is 7 units away from the y-axis. So this is 1, 2, 3. So this R dash would be over here. So let's join them together and see what kind of shape do we have. Okay. So here is this, and this. Okay. So this is a horizontal stretch over here. Now, is this concept of stretch clear to you, or I should give you some more examples before I go into this these functions? Yes, please tell me quickly. Is
Sir,
this
can you give another example?
okay? Let me give you one more example then. Let me draw one more triangle here. Now I have this triangle XYZ, okay? And I want to have a vertical stretch. That means I would be stretching this from this x-axis. And let's say this time my scale factor is 3, okay? The scale factor is 3 now. Okay. Now what is the distance of this point X from the x-axis? Tell me quickly. You will have to be quick. Yeah. What is the distance of this X from the x-axis? That is, come on, yaar. Why are you taking so long? Yes, Aman. What is the distance of this point X from the x-axis, beta? Hello, Asma. What is distance of X?
One.
Yeah, that is 1. It is 1, okay? So what should be the new distance of the point X from the x-axis if you consider this scale factor? Yes, Asma?
3.
3. So this is going to be 1, 2, 3. So this is the new location for this X dash. Okay. And similarly, Osgul beta, can you tell us what is the distance of this Y from the X axis? Osgul. Okay. Ayla bete. Ayla. Yes, Ayla. Ayla. Dua. Yes,
सर
go.
y का भी 4 ही होएगा.
What is the distance right
फिर
now?
like 3 points ऊपर जाए.
No, 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 no. Look at this. This is right now 1 unit away from the x-axis, and you multiply that 1 with the 3. You get 3. So this will be going from this x-axis 3 units. So like 1, 2, 3. So here it is your y dash. You were saying 4 units. It has to be 3 units. Okay?
सर मैं चलेगा 4 है. I'm sorry.
Okay, okay, okay. Fatma Amir bete, what is the distance of this point z from the x-axis? Yes, Fatma. Or Fatma Rauf if she's there.
4 sir.
4. And what would be the new distance of the z from the x-axis?
12.
12. So I'm going to count from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here is your z dash. And if you want to see that, how would this triangle look like? Look at this. And then you see this and this. So this is the stretched image of this triangle XYZ. So you see that every time, like you take the distance of x from the x-axis, you multiply it the scale factor and you get the new location of the point x from the x-axis. Okay, bacho? So can I move on to the stretch of functions? Or
Sir,
you
but how did we know that x-axis was the invariant line and not
Oh,
the
good,
y-axis?
good question. This will always be given to you, beta. This is like you will always be given
Okay.
two things. One thing is the information about the invariant line, that which one is the invariant line, okay? And then what is the scale factor? Acha, yahan pe, since you've asked really a very relevant and a good question, you see that whenever we are stretching these functions, we always have either x-axis as the invariant line or y-axis as the invariant line. So instead of saying, giving you these equations as x-axis or y-axis, he would rather say that there is a horizontal stretch or there is a vertical stretch. You see, if you look at these two situations here, in this case and in this case, this is a vertical stretch. If you have a vertical stretch, so which one is your invariant line? Hmm? Is that x-axis?
Y-axis.
X-axis, yeah. And similarly, you look at this one here. This one is a horizontal stretch. So if you have a horizontal stretch, the invariant line is going to be the y-axis. Invariant line is going to be the y-axis. ठीक है बच्चों? अच्छा, अब यहाँ पे I'm going to tell you now about the stretch on functions. Okay? So please be alert and ask me immediately whenever you feel like. Don't delay that. Okay? So I'm going to let me keep these drawings right now over here, and I can clean the area that I can. Okay, so that I just want to keep these triangles here. Okay, so now, guys, look at this triangle over here. I mean, this curve. Okay, the equation of this curve is right now y equal to 2x square minus x minus 6. Okay, now just keep a look at these points right now. Okay, now if I stretch this vertically, would these 2 points change their positions? Hmm? Yes.
No,
Why not?
because it'll be extended upwards.
No, 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 no. You see, why was this point changing its position? Because it was 1 unit away from the x-axis. What is the distance of this point that I'm pointing here from the x-axis?
0.
0. It is 0. So these 2 points will remain invariant. That is why we call these lines invariant lines, because they don't change their positions. Okay. So any point that is there on the invariant line, that will not change its position. Similarly, look at this point over here. If I stretch this horizontally, this point will not change, because when you stretch horizontally, you look at the distance of the points from this y-axis. So since it is already on the y-axis, its distance from the y-axis is 0. So this will remain unchanged. Okay? Acha. Now, whenever you have y is equal to f of x and you transform that onto a times f of x. Okay? Now, before I go into this, look at these vertical stretches. Which coordinate is changing? Is that the x coordinate or the y coordinate? When you have the vertical stretch, which coordinate changes? The x
Is
coordinate
the y
or
coordinate.
the y?
Y coordinate.
Yeah, the y coordinate. Okay. If your y coordinate is, let's say, if you have a point which is a comma b, after a vertical stretch with the stretch factor k, this becomes a comma kb, because the new y coordinate would be k times the original y coordinate. Do you agree with this or not? Yes? This becomes k times. Yes or no?
Yes.
Look at this b. The y coordinate right now is 2. And what is the y coordinate of this b dash? That is because the scale factor was 2. So now the y coordinate is 4. Look at this c right here. Its y coordinate is 4. And then you look at the c dash. Here the y coordinate is 8. Now the same happens when you stretch a curve. Okay, now look at this. Let me note down some points over here on this curve. Okay, now when you have x, for example, let me take this point here. This point over here is 3 comma 10. I think this point is 3 comma 10. This is
2 comma 10 ne? Sorry, okay, 3.
this is 3 comma 10. Hannah? If I put 3 here, this is 2,
Yes.
9 are 18. 18 minus 3 is 15. Yeah, this is 3 comma. So this is the point here, which is 3 comma 9. Okay, this is 3 comma 9. So you have to see that, like, this point is 3 comma 9. Guess what would be the image of this point if I stretch this vertically with a scale factor half? With the scale factor half. Yes, tell me, what should be the image of this point if I stretch the whole curve with the scale factor half vertically? If I stretch this vertically with the scale factor half. Yes. Come on, tell me quickly.
3,
4.5.
4.5.
3 comma 4.5. Okay, let's check that. Okay, I'm going to multiply the whole curve here with half. Okay, you will see that this is going to be 0.5. Okay, now look at this. This is 3 comma. Can you see that here is this 3 comma 4.5? Do you agree or not? Come on, tell me. The new point is 3 comma 4.5. Please be very quick. We have to cover a lot of part today, a lot of content to be covered today. So you have to be quick. So do you see that this point was, let me remove this again so that you can see that this point was, look at this. This is 3 comma 9 over here. And what happens to it when I multiply this with 0.5? And it goes at 3 comma 4.5. Okay, now look at one more point here. Here is a point which is this is minus 2 comma 2. This point is, but so can you see this? This point has the coordinates minus 2 comma 2. Now if I stretch this curve right now with a scale factor 2, what should be the new point? Yeah, if I stretch this
Minus 2, comma 4.
minus 2 comma 4. Okay, so let's multiply this equation by 2. So this 0.5 would be removed because 0.5 times 1 is going to be, so I am going to make this 1 now. Okay, So let me remove this 0.5 from here. Okay, so you see, so can you see this point now here? This point is 2 minus 2 comma 4. This has been moved on to minus 2 comma 4. So that should be an enough evidence for you to believe that if you stretch a curve vertically, the y coordinates, they change k times. The y coordinates change k times. And that is how you write the equation of the new equation of the stretched function. Okay, you have to multiply the whole of the function with a number, which that number is basically the scale factor. That number is the scale factor. Now, if it is clear to you, can I take you to the horizontal stretch? Yes. Shall we go on to the horizontal stretch,
Yes,
Bacho?
sir.
Okay.
Yes, sir.
Okay. Do you remember I told you yesterday that whenever you have a horizontal transformation, the things always go opposite way. I mean, the opposite to the normal arithmetic rules. Okay. Just see what is going to happen now. Now you have this equation here, y is equal to x squared minus x minus 6. And right now, let me remove something, some drawings from here. I'll have to clear all of this. Okay. Now, let me write down the equation so that now the equation right now is y equal to 2x squared minus x and minus 6. Okay. Just look at this. What is going to happen now? I'm going to change all the x's with the 2x. Okay. That means I'm going to stretch this horizontally. Okay. Now this means that if your scale factor is 2, so technically all the x coordinates distance should be doubled from the y-axis. Yes or no? Look at this distance is 2 over here. This distance is 1.5 over. I'm not saying going to say minus 1.5. I'm using the word distance. Okay. Look at this distance over here. That was 4 over here. Okay. And do we have any other prominent point? Maybe this looks to be 1 over here. Okay. And this looks to be 1 over here. Now check all these distances, what will happen to them. Okay, I'm going to add a 2 over here. Okay, so I have 2 over here. I have 2 over here. What has happened to these distances? Come on, tell me quickly.
They have decreased.
Now, have they been doubled or halved?
Sir, half.
They
Half.
have been halved. Oh, you see, that is what happens in your horizontal transformations. You can see that there is a number 2 over here. So rather than getting doubled, they are getting halved. So that is what happens in your horizontal stretch. Okay, now let me bring it back in its original form. Okay, let me remove these 2's here. Okay, remove these 2's here. Okay, now I'll be putting half over here and then you see what is going to happen. Okay. I'm going to put a 0.5 here. I'm going to put a 0.5 here. Now see what has happened here. What happened to these distances?
Double. They're
They
double.
have been doubled. They have exactly been doubled here. Okay. You see that this new distance is, this is going double. Okay. I think that was 3.5 and sorry, it was 3 and now it is going at 6. Look at this was at 1 and now it has gone at 2. This was at 1, now it has gone at 2. This was at 1.5 and now it is at 3. This was at 2 and now it is going at 4. Okay, so guys, let me generalize this. You people note it down that if you have y is equal to f of x, okay, and you transform this onto y equal to a f of x, this means it's a vertical stretch. It is a vertical stretch. with k equal to a, with k equal to a. And similarly, if you have y equal to f of x and you transform that onto y equal to f a of x, so this shows a horizontal stretch, a horizontal stretch, okay, with with now what would be the scale factor, bacho? If you see a being multiplied with the x,
Sir, 1 over A.
1 over a. God bless you, beta. This is going to be 1 over a. So time to go back to the book and see what do we have there. So just to remind you from the book, you see that, let me enlarge this a bit. Guys, you see, is this book being shared with you? Yes, this is being shared. Yeah. Okay, guys, look at this. You can see that your whole of this equation is being multiplied by 2. If whole of the equation is being multiplied by 2, so that is basically a vertical stretch. And you can see that all these distances being doubled here. Should I explain this, or it is clear to you now that how these distances are being doubled? Is that clear? Hello? क्यों भाई?
Yes, sir.
Okay. Okay, now let's look at the horizontal stretch here. Yeah, look at this. Now, if you see that these x's, they have been doubled here, and you see the curve shrinking towards the y-axis. Okay? So that's what happens in case of horizontal stretch. Let's move on to the exercise. Now it's time for you to respond now. Okay? So I'm putting it here. You first try it yourself and then I'll be asking you. Look at this first question now. It says y is equal to 3 times f of x. So Eamon, beta, can you tell us what kind of stretch is this? Is this the horizontal stretch or the vertical stretch? Eamon.
Vertical.
Yeah, very good. It's vertical stretch. Okay, Ozgul beta, please tell us. Okay, now these people whose names are starting with A, I have asked them already. Let me go to down the list. Okay, Zuna beta. Zuna, can you tell me that what would be the image of this point 6 minus 1 after this vertical stretch with a scale factor 3? Please, you have to be quick, Zuna. What would be the new location for this point, which is right now 6 minus 1? Okay, Zuna has written in the... Yeah, if your mic is not working, you can tell that in the chat. Okay, Zainab Tariq, can you tell us the new location for this 6 minus 1?
6 minus 3.
6 minus 3. Very good. Okay, that's great. Okay, Zainab Sanaullah, tell us what is happening in the part B. Is that the horizontal stretch or the vertical stretch?
Horizontal stretch.
Okay, okay, thank you. Zainab Heather, she says it's a horizontal stretch and she is quite right to say that. Can you tell us that what is going to be the scale factor of this horizontal stretch? Yeah.
1 by 2.
Exactly. Excellent. Mashallah. Mashallah. Okay. So I'm not going to see what would be the new images. I'm going to take you guys to the second question. Okay. It says find the equation of each graph after the given transformation. So yes, Zainab Heather, bete, what would be
Yes, sir.
two parts A, 2A's answer?
1 second, sir. Stretch parallel to y. Parallel to y-axis would mean horizontal stretch.
No, it's vertical stretch, beta, parallel to y-axis.
So shouldn't that be a horizontal stretch?
Parallel to y-axis is a vertical stretch, beta. Parallel to y-axis. If
That
it's
way it will be 6x square.
yeah, exactly. This would be 6x squared. Thank you, beta. Okay, Zainab Atif, can you hear us?
Yes, sir.
Okay, beta, can you give us the equation for 2b?
Yes, it will be 3x cubed minus 3.
Great. So the whole of this is going to be multiplied. Mashallah, yaar, very intelligent bache. Okay. Zara Sajjad, can you tell us about the C part? Yeah.
Yes, sir.
Yeah. So what's
Sir,
the
it will be
uh-huh.
2 over 2 उसके ऊपर x minus 1 plus 2.
Eh? Why are you saying this? You're looking at the answers. Hmm? Hmm. Okay, did you see that from the answers?
जी सर एक सेकेंड अभी मैंने खुद नहीं किया.
हाँ देखा. अच्छा ताहिरा आप बताओ, ताहिरा बेटे आप बताओ C part. Don't give me the final answer, just tell me in this form, Yeah. Yeah. Tahira, Zoha, Sayyida Zoha, Shazreen, Shazreen,
Sir, can you repeat the question? My
two
internet
C,
lagged.
two part C beta. Tahira, I can't respond to you beta. Abhi Roshna, sorry, Shazreen is thinking. Hmm.
I can't get this one.
Come on, this is going to be simply half into 2 raised to power x plus 4. Whenever it says parallel to the y-axis, that means it's a vertical stretch, okay? So you only have to multiply the whole of the equation with the scale factor, okay? Now someone from you, she just looked at the back for the answer. So when you multiply this with half, so this becomes 2 raised to power x minus 1, and half into 4 is going to be 2. That is how she must have seen the answer at the back. Okay. Now, Samin Zara Bete, can you tell us about the 2D? See, now this is the stretch parallel to the x-axis. This is, yeah,
Wait, if a
Sir?
stretch is parallel to the x-axis,
yeah.
sorry, the y-axis, how is it a vertical stretch? क्योंकि vertical stretch तो x-axis पे होता है.
Come on, yaar, dekho. You have a point over here, and this moves to this position. So is it going parallel to y-axis or parallel to the x-axis? Come on.
Oh, okay.
Okay.
Yeah.
Yeah. Okay. Now it says after a stretch parallel to the x-axis, you have to tell me what is the new equation. Yeah. Samin. If Samin can. Yeah. Yes.
Sir, I don't understand.
Okay. Roshna, can you tell us the equation for the D part, bete?
Sir, if it's parallel to the x-axis, मतलब कि वो horizontal stretch होगा तो 2x square minus 4x plus 10.
Hi.
सर
अच्छा
इसको divide by 2 नहीं करेंगे?
बेटा आप इसको ये लिखेंगे 2 into half. I just wanted to in this form 2 into half x square minus 8 into half x and then plus 10. If your scale factor is 2 here, so you have to write the reciprocal over here, because if your, let me tell you again, if your y is equal to f of x and you change that into y is equal to f a of x beta, then your scale factor is 1 over a. I just told you in the previous slide, okay? So k is 1 over a. So if you see that the scale factor is 2, so it means you need to have half over here, okay? And it's a horizontal stretch. Not the whole equation would be multiplied with the scale factor. It's only the x's that has to be changed with the half x, okay? Now, Noor Zeb, beta, can you tell us about the equation of the E part? Quickly, the time is running out. Yeah. Noor Zeb. No. Who is above Noor Zeb? Minahil Zahid. We might be getting over with this time now, and that our video might end. Okay, the scale factor
सर
is,
मुझे ये समझ नहीं आया.
look at this. This is scale factor is 1 over 3. So the equation would be 6 into 3x cube minus